Right, guys. So in 1.1a lesson, we're going to be examining experimental and theoretical probability in this activity. I have a bag. I have a bag here, and in this bag, I have a total of 12 green and blue tiles. Okay, I'm not looking in the bag. I'm going to make a guess as to how many green tiles the bag contains. Okay, so I'm going to draw blue. Okay, so I just put it back in. So I'm going to put a B for blue. Second draw, blue. Third draw. Sorry, it's backwards. The screen's backwards to me. Green. Fourth draw, blue. Fifth draw, blue. And the sixth draw, blue. All right, so it said draw a marble tile without looking in the bag, record the color, replace it, redraw, record, replace, do this 6 times. So there it is. Okay, based on your experiment, what portion of the 6 draws were green? Okay, so I had 1 green of 6. You know what? We're not going to do 1/6. That's the probability. We're just going to say 1 was green. Okay, based on your experiment of 6 draws, how many green tiles do you think are in the bag? Okay, so remember there are 12 green tiles in here. Okay, my guess, 2? I think there might be 2 of the 12. Okay. All right, now we're going to do this 18 times. Okay, so I'm going to try to do this quickly here if I can. Green. Put it back in. I'll write it down in a second. Blue. Green. Green, blue, green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, do 3 more. Blue. Green. Blue, green, blue. 3 more. Green. Green. Blue. Green. 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 Blue. Green. Blue. Blue. Green. Blue. And then the last 3. Almost there, guys. Green. Green. Blue. Green. Green. Blue. All right, we just repeated that 18 times. Based on this experiment, what portion of the 18 were green? We had a whole bunch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of the 18 were green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I wanted to just double count. All right, based on my experiment of 18 draws, how many green tiles do you think are in the bag? Okay, so out of 18, I got 11. Gosh, this original guess of 2, I've got to up it, I think. Okay, maybe 3, maybe 4. I'm going 4. Okay. All right, so that's my guess now of what's in the bag. I'm going to just set my bag off to the side here. Okay, probability has standard notation. In this situation, we understand the probability of the P parentheses G means the probability of drawing a green tile. So this is a certain kind of notation, okay? To write P of G, we need to know the observed frequency. Okay, observed frequency, that is how many times we saw green come up when we reached in and grabbed. Okay, the total number of trials, well, we did 2 experiments up here. Total number of trials here are 6. Total number of trials here are 18. All right, so here's the formula. Here's the definition and the formula for experimental probability. Experimental probability is the ratio of the observed frequency to the total number of trials. Okay, so here's the formula. Probability of green. How many times did I see green over how many times did I draw? Okay, for each of your trials on number 1, write your groups, mine, probability of green as a simplified fraction and decimal. Okay, so my probability of green up here, and this is what I started to do with this 1/6, and I realized I wasn't quite there yet. Okay, so I had 1 green out of 6. Let me scooch that up so we can see it. I had 1 green out of 6. I'm going to calculate the decimal in a second. On my second, my B experiment here, I had 11 out of 18. 11 greens out of 18. Okay, let me grab my calculator. I just have my phone here that's handy. All right, calculator. So I've got 1 divided by 6. 1.6 repeating. That 7 on the end is just rounding. That 6 goes on and on and on and on. So point. Okay, let's try 11 divided by 18 now. Ooh, much different. 0.61 repeating. Okay, you can see with an experiment, there's some flexibility. Okay, it's a chance thing. All right, so what do you think would be in the bag if the probability of green is equal to 0? Okay, does everybody understand that would be a 0 over a 6? 0 greens showed out of 6 draws, or 0 greens showed out of 18 draws. There would be no green in the bag. What do you think probability of green equal to 1 would be? That would be 6 greens out of 6 draws, or 18 greens out of 18 draws. So all green in the bag. Okay, let's go to the next page. By the way, this has been modified. This 1.1a lesson has been modified from what we do in class. Okay, so you're going to have to skip a bunch of these on the front page of the original that's posted to you. Okay, we didn't do, okay, if we were in class, you would have been doing the drawing and recording with your partner. Okay, so I'm just doing a modified version of this. Okay. Explain why the probability of green tiles is a fraction between 0 and 1. Okay, well, there can't be fewer than 0 green tiles. Oops, tiles. That's a 0% or 0. Okay, and then there can't be more. There can't be more than 12 green. Well, yeah, 12 was in the bag. 12 tiles in the bag, 12 green tiles, which would be 100% or one whole. Okay, so I want you to think about that. That's a very important concept. Okay. Explain why the probability of green tiles is a fraction between 0 and 1. Okay, so there can't be anything under 0 green tiles. Okay, so your chances of getting that starts at 0, and then you have any number of green tiles between 0 and 12. That means that you would have any percentage between 0 and 100%, or any whole number between 0 and 1. Okay, that's a very important concept. Okay, how does knowing the probability of green tiles help you know the probability of blue tiles? All right, so both the green and the blue, both green and blue tiles must, let me put probability, both green and blue probabilities must add to 1, since that is 100% of the bag. Okay, I'm going to record a prediction of how many of the 12 tiles are green in my bag. Okay, my prediction, what did I say on that last page? I said 2, and then I changed my prediction to 4. Okay, I'm going to say 4. Okay, now we're going to look in the bag. I'm going to pour them out right here, guys. Wow, look at that. Okay, so green tiles, 1, 2, 3, 4, 5, 6, 7, 8 of them were green. I was way off, huh? Okay, count how many blue and green tiles are actually in your bag. What is the theoretical probability of drawing a green tile from your bag? Express your answer as a simplified fraction and as a decimal. Okay, so the deal is we just did 2 experiments, one with 6 draws, one with 18 draws, and we got a certain probability. An experiment is exactly what it sounds like. It's an experiment. It might not be exactly what's going on. There's a lot of chance going on inside that bag for every grab. Okay, so I have 4 blue and I have 8 green. Okay, 12 total. Now the probability of getting a green in theoretical probability is what actually is in the bag. Okay, that's going to be 8 of them out of the 12. Well, 8 out of 12 reduces to 2/3. And then it also wanted it as a decimal. So this is our simplified fraction. And then our decimal would be 0.6 repeating bar. Okay, looking back, comparing this actual theoretical probability to our experimental probability. Okay, take a look at this, guys. Way off, way different when we only had 6 grabs. But when we took that up to 18 grabs, wow, that was so close to what actually is in the bag. Both of these were different experiments, and these are experimental probabilities. And then we looked in the bag to see what actually was in there. and we got, this is the theoretical probability. All right, so let me get these tiles out of the way. Let's put some definitions down. All right, theoretical probability. The probability of events that come from a sample that doesn't look like sample, looks like I forgot the P. There we go. The sample space of known equally likely outcomes. I'll explain that in a minute. P of an event equals number of favorable outcomes over number of possible outcomes. Okay, equally likely outcomes. If in my bag I had different sized tiles, do you think my hand would be equally as likely to grab a smaller one versus a larger one? No. Okay, so equally likely means it all has to be fair and the same. Okay, so you saw those green and blue tiles, they were all the exact same size and shape. Okay, so we had an event, this bag, 12 tiles, and then we were looking for how many greens. That's the number of favorable outcomes we counted out of so we have the number of favorable outcomes is green. So this is what actually is in the bag. We did the number of favorable outcomes to the number of possible outcomes. So we had 8 actually that were green out of the 12 possible tiles that were in there. Okay, now let's talk about the experimental probability. The probability of events. Probability of events occurring. You know what? I think there's 2 R's in occurring. When an experiment is conducted. So the probability of an event equals the observed frequency over the number of total trials. Okay, so here's what I was getting turned around because I didn't notice that one was theoretical first. Okay, since we did experimental first in the actual last page here. All right, the probability of events occurring when an experiment is conducted. So we first did an experiment that had 6 trials. 6 went down in the denominator. That was the number of total trials. And out of those 6, I think we only had 1 green. So that was how many that we saw. Observed frequency is what do we see and record. Okay, and then we did an 18 number of total trials, and we recorded how many we saw, and that was 11. Okay, so that's the difference between those two. Okay, now how my experimental compares with the theoretical. 6 trials in experimental was much lower probability of a green than 18 trials was. This is being compared to the theoretical probability of 0.6 repeating bar. Okay, so I hope that you noticed my 18 trial experimental probability compared to my theoretical probability was almost spot on. Okay, that doesn't always happen, but it was pretty close. Okay, and then I hope that you noticed when I did 6 trials in my experimental probability compared to my theoretical, we were pretty far away. Okay, the 6 trials was much lower to get a green. Okay. All righty. Suppose you had a bag of 1,000 blue and green tiles. How many times do you think you would need to draw to make an accurate prediction of the number of blue and green tiles that are actually in the bag? All right, so you kind of you just noticed, I hope, that 6 wasn't that many draws to get an accurate account. 18 was much more accurate. So if we have 1,000 blue and green tiles, okay, we're gonna need to do it at least, what would you say? Okay, notice that we did 18 draws and we had 12 tiles in the bag. Okay, and when we did 6 draws, that's half the amount of tiles. It was very inaccurate. So I would say probably 1,500 to 2,000 draws. Okay, we would need a minimum of 1,500 to 2,000 draws to get an accurate representation of what actually is in the bag. The more draws gets more of an accurate picture. Theoretical probability is more likely to be closer to experimental probability the more draws you have. Okay, that should make sense. All right, you're a teacher in a 7th grade math class and you want to create an experiment for your class with red, yellow, and purple marbles in a bag. You want the theoretical probability of drawing a red marble to be 1/4, the theoretical probability of a yellow to be 1/4, and the theoretical probability of a purple to be 1/2. If you want a total of 120 marbles in the bag, how many red, how many yellow, how many purple should you put in the bag? All right, so we need to see if we've got 120, don't we need to see what 1/4 of that would be? Okay, so basically for the red, we are looking for how many out of 120 would get us 1/4. Okay, so let's look this way. Wouldn't we multiply this 4 by 30 to get to 120? Therefore, 30 red marbles should be in the bag. Okay, for yellow, you good with the same thing? Okay, yellow, we wanted the same probability 1/4. So again, question mark over 120 equals 1/4. So we would need 30 yellow marbles. How many purple marbles should be put in the bag? Well, we want to know how many purple over the 120 gets us. This time, purple is 1/2 of the bag. You guys understand that we would multiply by 60 here. Therefore, we would multiply the 1 by 60. So we would need 60 purple marbles. Okay, take a double look and make sure that 30, 30, and 60 does total the 120 marbles that are in the bag, and it does. Okay? All right. This is very important. Finding the likelihood of an event. Okay, so here we had a question before about why is the probability between 0 and 1? Okay, and here is a picture of the probabilities that are between there. Okay, probability is a measure between 0 and 1, as shown on the number line, and can be written as a fraction, decimal, percent. All right, tell whether each event is impossible, unlikely, as likely as not, likely, or uncertain. So notice these words up here. Okay. Then tell whether the probability is 0, close to 0, a half, close to 1, or 1. Okay, if I roll a 6-sided number cube, a standard die, and the number is 1 or greater. Okay, so if let me grab my dice here. Where's my dice? Here, this one. Okay, how many numbers on this die are are 1 or greater? 1 or greater. All of them. All of them are. So this is going to be certain or 1, okay, or 100%. All of them would be. Okay, you roll an odd number on a standard die. Well, there are 3 odd numbers out of 6. 3 odd numbers, odd meaning 1, 3, and 5, out of the 6 numbers. Okay, so 3 out of 6 would be, that would reduce to 1/2. That's as likely as not. Fancy words, meaning it's equal. It's an equal chance to get odds and evens. As likely as not, or 1/2. Okay? All right, number 13. A bag contains 10 tiles in it and 2 of them are green. What is the probability of picking a green? Okay, let me stick that right up there. All right. Do you understand that that would be 2/10? 2/10 would fall somewhere over here. That's not 5/10. 2/10 is over here. It's not impossible. It's not 0/10, but it's somewhere like right here in this unlikely spot. Okay, so unlikely, just so you know, goes everywhere from just to the right of 0 and just to the left of a half. Same with likely. You're likely if you're over a half, but under 1. Okay, so this would be unlikely, or closer to 0. Okay, find the probability of an event described below. Use probability notation. Remember that's P with parentheses what you're finding, and write your answer as a reduced fraction. What is the probability of rolling an even number on a standard cube? So here is my probability notation. That would be 3 chances out of 6. Reduced as a fraction would be 1/2. What is the probability of picking a purple marble from a jar with 10 green and 8 purple marbles? 18 total marbles, that's key. Okay, so the probability of picking a purple would be 8 out of 18, not 8 out of 10, 8 out of 18. That reduces to 4/9. All right, you try number 16, pause me, and then click me back on to check. A spinner has 3 sections, red, yellow, and blue. The table shows the result of Nolan's spins. Find the experimental probability of landing on each color. Write your answers as a fraction in simplest form. Okay, it's first very important to point out these sections must be the same size for this to be an accurate experiment, okay? So we've got 10 reds that popped up, 14 yellows that popped up, and 6 blue that popped up when Nolan actually did the spinning, okay? So it's important to add these up, 30 spins total. Notice that was not given to us in the problem. Sometimes it'll say Nolan spun 30 times, and in the chart below, there were his findings, okay? But that was not given. You know, the experimental probability of getting a red would be 10 times out of the 30. Probability of red, remember we're going to be really official with our notation. 10 times out of 30, that reduces to 1/3. Fraction in simplest form. Yellow, probability of yellow, 14 out of 30. Okay, 14 out of 30, that reduces to 7/15. And then the probability of blue is 6/30, which reduces to 1/5. Okay, now here's something that's very important to notice. Take a look at all these. Do you notice anything about those 3 fractions of the entire bag? Okay, wouldn't they add to one whole? 30/30. If you added these up, shouldn't they add to one whole? So 10 plus 14 is 24, plus 6 is 30/30. I'm going to make that note down here. 30/30 equals 1 complete bag. Okay, that's important. You might have a question that has like, how many blue would there be if you had 10 red and 14 yellow, and there were 30 altogether, okay? All right, so that takes care of 1.1a, very important 7th grade standards in this lesson we just discussed, okay?